Hello students, welcome to Unit 4 Notes, Section 4.1. This is the first lesson of Unit 4. At this time, you can pause the video, do the warm-up, and then check your answers. I already did the warm-up to save some time on the video. Okay, but after that, we can move on. So we are working with congruent figures today, and so we're working with congruent polygons, triangles, polygon, any type of polygon. It could be a square, rectangle. And what we'll learn is to recognize congruent figures and their corresponding parts. So corresponding parts, we really need to be observant this lesson, okay? We're going to be focusing in a lot on the corresponding parts and keeping to the particular order that we're supposed to be sticking with. So, congruent figures. Congruent figures have the same size and shape. So for instance, a translation, translation, which is a slide, a flip, which is a reflection, and a turn, which is a rotation, are all maintain size and shape, making it same size and shape, making all of these congruent. So 3 ways to make them are a slide, flip, and turn, which I just wrote down. Congruent polygons have congruent corresponding parts. They're matching sides and angles. Okay, so what we know, for instance, in a flip, that this part here is congruent to this part here, that this part here is congruent to this part here, that this bottom part is congruent to this bottom part, and this fourth side is congruent to this fourth side. So in a flip, you have the mirroring items here, the mirroring items here, the mirroring items here, and these are mirrored as well. So those are corresponding parts. We also have this. We have angles, for instance, this one and this one are congruent. Look at this is between the 4 tick marks and the 1 tick marks for my side. So between the 1 and the 4 tick marks for my side, I also have just this 1 lingering tick mark for angles. This one would be 2. I can go in order. I like to go in order. This one I'm going to make 3. And then this one I'll do 4. 1, 2, 3, 4. 1, 2, 3, 4. So the important thing is that the order is consistent. So for instance, 1 on my angle is between the 1 and the 4. The 2 tick marks for my angle is between 1 and 2 and 1 and 2. The 3 tick marks here is between 2 and 3 and 2 and 3. And the 4 tick marks for this angle is between 4 and 3. Now it doesn't matter. It doesn't matter how many tick marks I use as long as the order is correct. Okay? So we just want to make sure we stick with that particular order. Again, like 1 and I could switch these if I wanted to. That's fine. But then I need to also switch these, is what I'm saying. Okay, so that's legal. That's totally fine. But the order has to be consistent, as in this down here has to match this here. But I'm going to go back and fix everything to the way it was. So congruent polygons have congruent corresponding parts. They are matching sides and angles. Matching vertices are corresponding vertices. Okay, so when you name congruent polygons, always list corresponding vertices in the same order. So for instance, C corresponds to R, B corresponds to Q, A corresponds to P, and X corresponds to Y. So we should go in order when we do A, C, B, X. That has to be congruent to P, R, Q, Y. You don't get the option of mixing and matching. A in black, C in blue, B in pink, and X in green have to match P in black, R in blue, Q in pink or red, and then Y in green, which is why this order matters. AX, this segment here, AX corresponds to PY. They're both congruent. Angle B corresponds to angle Q. Point C corresponds to point R. So we're talking about congruence for these angles and for the side lengths. Okay. So in this one, TJD is congruent to RCF. So TJ, whoops. So TJ, whoops, hold on. So TJ is congruent to RC. Oh, this is not working. So TJ is congruent to RC. FC is congruent to JD's, yep. And then FR is congruent to DT. And the way I got this was I did TJ is congruent to RC, the first two letters. JD and CF. So JD is the second one, and CF is the second one as well. Okay, and then DT and FR are also congruent. And so next we can do our angles. So if you notice between 1 and 2 here, I'll just put, I don't know, how about 1 tick mark? And then I'll put 1 tick mark between the 1 and the 2 sides, right? So these are my angle tick marks. So I'll do that. And then I'll do maybe 2 right here, between the 2 and the 3, and then between the 3 and the 1. Okay, so that's the corresponding congruent parts on the actual diagram, but we can list the congruent corresponding parts as well. And I don't need to use this diagram to do that. I can actually use the statement. So the statement gives me all the pieces of information I need. What I know is angle T is congruent to angle R, angle J is congruent to angle C, and angle D is congruent to angle F. Also, if I had, for instance, DJT, that angle is congruent to FCR. So I can either list the 3 letters or just the 1 letter in my congruent statement. And also the same thing go for my side. So let's do a couple of these. So I'm going to say TJ, side TJ is congruent to side RC. Side JD is congruent to side CF. Those are the second 2. Now the first and last one. So I'll do TD is congruent to RF. So I've done all 3 combinations. I'm now going to do the same thing for the angles. So angle T is congruent to angle R. Angle J is congruent to angle C. And angle D is congruent to angle F. And there we go. Now we can see it up here, T and R. T has 3 tick marks and R also has 3. So we can pull it all from there. Okay. All right, the next one, again, we don't even need a triangle. We're just going to use this right here to list all of our statements. So, yep. So I'm going to say angle. So I'm going to say WY, side WY is congruent to side MK. Side YS is congruent to side KV. And side WS is congruent to side MV. So the first and last letters of both. And then the next one I'll say angle W is congruent. So angle W, angle Y, and angle S is congruent to angle M, angle K, and angle V. So that's all 3 of them in order. Okay. All right, so these are actually problems, 1 and 2 are problems within your textbook, but I incorporated them here because I just want a little extra practice. So builders use king post truss below the left, well, it's really to the right, for the top of a simple structure. In this truss, ABC is congruent to ABD. So ABC, so triangle ABC is, so this one right here, ABC is congruent to triangle ABD. List the congruent parts. Well, this is cool, so I'm going to just write out what I know about them. So AB is going to be congruent to AB. Oh, that's a reflexive property, right, of congruence. The next one's going to be BC is congruent to BD. So I'm taking AB is congruent to AB. And this one on the left, this one on the right. Then this one on the left, BC, is congruent to BD. And then AC is going to be my last one. AC is congruent to AD. Okay, so AB congruent to AB, well, that was easy. Then BC and BD. And then AC and AD. Notice this 1 tick mark, but I'm not going to use 2 tick marks because that would match these parts. The 1 tick mark is representing that AB, no matter if I look at just the left or just the right, covering this up. Can't really do that well on the iPad, but that just the left and just the right both share side AB, and that is congruent with 1 tick mark. Now, notice that I can't really use one letter, angle A congruent to angle A. I can't really do that because this angle A and this angle A, but there's also one big angle A. So I'm not going to use one letter. I'm going to use all 3 letters. So here's what I suggest you do when you're doing 3 letters about congruence. Go in order. So do angle ABC, angle BCA. See what I'm doing? I'm going ABC. Then I'm going to go BCA, and then I'll go CAB. So I'm going to just cycle them through. So I'm going 1, 2, 3, 2, 3, 1, 3, 1, 2. So I'm going left to right, but I'm just starting at each one uniquely. So CAB, be careful, don't do CBA. I almost messed up. But again, ABC, BCA, CAB. I'm reading left to right. I'm keeping the order ABC in order, but I'm just starting at a new letter. Okay, so again, go left to right, start at A, go left to right. Start at B, go left to right. You run out of room, and then you have to kind of go back to A and to reset your cycle. Then start at C and go left to right, and that will make you go back to A and B. And now I'm going to do that same thing for the other side. So congruent, congruent, congruent. I'm going to say angle ABD, then angle BDA, and then angle DAB. Again, I'm just reading left to right, left to right, left to right for all 3. And when I run out of room, I go back to the front and I start all over. So where's ABC? This is ABC. Ironically, these are going to be right angles because they're shared and they're congruent, and this is a straight line. So we know that this is 180, making each one of those 90 degrees. BCA is this one right here, and that's congruent to BDA. Notice I used 1 tick mark for each one, even though these have 1 tick mark, because those are special right angle 1 tick marks. Okay, so we can do that. And then the last one is CAB, which is over here. So CAB and DAB. So that gives me the 2 that I need right here. Okay, and that's those are the exact triangles. Those are the corresponding parts, the congruent corresponding parts. All right, the next one, the attic truss above, which is really not above. So let's get rid of these words. These are screenshots from the textbook. So really, I should have just said below right. and then this is below right. Provides open space in the center for storage. Okay, so this is used, these are really cool. You know what? I'll show you a picture. Let's go to Cape style house. So Cape style house, nope, house. These are, you're probably familiar with these. There's a lot in North Kingstown, but these Cape style houses allow for, see this, instead of it being an attic space, there's actually livable space there. So these rooms are built. So Cape style house upstairs. Let's see if it shows pictures upstairs of it like a cape. So you have these open spaces. Here's a great one. So there you see your open space where the attic is open. So this is kind of like what we're looking at when we look at truss. So this truss has allowed there to be open space in the attic, maybe for for standing storage, or for even having a room up in the attic space. So here, EFG. Now, when they make these in factories, they just repeat this process over and over, and they take the shape of an attic when they're all nailed together. But EFG now and HIJ are congruent. So what you're going to see here is you're going to see this congruent to this part congruent to this part, and this part congruent to this part. And they all need to be congruent, because if not, we're going to have a major problem when we go to put them together like a puzzle. Okay, so these angles are congruent, these angles are congruent, and these angles here are congruent. So we're going to have a major problem if they're not perfect, because as we go and repeat, our wall needs to be parallel or perpendicular to the floor or the attic or whatever else. So we got to repeat them perfectly. So what I'm going to do is just list out all those corresponding parts. So the first one is going to be, I think, my sides. So EF is congruent to HI. FG is congruent to IJ. And I'll keep with the order. So GE instead of EG, I'll say GE, which is going from left to right. So I ended at G. I got to go cycle back to GE. I got to do the same thing here. JH. Order's going to matter here. You have to go in perfect order. And this next one is going to be angle EFG. Then it'll be angle FGE. And then angle GEF. So again, I'm reading left to right, left to right, left to right for each one of these. Same thing here, left to right. Congruent, congruent, congruent. Angle HIJ. Angle IJH. Angle, I don't like that one. Angle IJH. Okay, and angle JHI. And those are 3 angles. Again, because there's so many angles shared, you can't use 1 letter, you have to use 3. Next one. Ooh, look at this. We have a rocket ship. We have a rocket ship with NASA rocket ship. Obviously, textbook is a little outdated. We are now talking about SpaceX launching rockets into space instead of our NASA, simply just our NASA program. This is the NASA, looks like Discovery. Yep, NASA Discovery. And if you'll notice, the fins kind of look like a polygon with 1, 2, 3, 4, 5 sides or so. 2, 4, 5. So a pentagon. Yep. So they are odd-looking pentagons, but they are pentagons. So it says the fins of a space shuttle suggest congruent pentagons. Find the measure of angle B. Well, here's what's really cool. If we have, we can find all the angles. The first question is, how many degrees in a pentagon? Well, a pentagon is composed of 1 triangle, 2 triangles, and 3 triangles. So it's if a triangle has 180 degrees, but we have 3 triangles, we then would say that it has 540 degrees. That's just one way of finding it. But don't forget that there's a formula for finding it. So if you don't want to break it into the triangle form, what we could do is we could do this thing called n times n, n minus 2 times 180, or 180 times n minus 2. N means the amount of sides that you have. So where n is the amount of sides. So what you do is you just put in, wait, what color am I supposed to be using? So I use green, so it's supposed to really be light pink, light purple. Okay. So if we were to evaluate that, we would say 5 minus 2 times 180. What this does is it gives us 3 times 180, which is 540 degrees. And this will work everywhere. Think about a triangle. Triangle has 3 sides. So 3 minus 2 is 1. 1 times 180 is 180. Think about a square or a rectangle, anything with 4 sides, like a trapezoid. 4 minus 2 is 2. 2 times 180 is 360. So there are 360 degrees. Okay? And it's going to travel on. A hexagon has 6, so 6 minus 2 is 4. 4 times 180 is 720. So pretty much, starting at a triangle that is 180, you're going to add 180 on for every additional side, because it's going to, in theory, create one additional triangle. So there's 540 degrees. Why did I do this? Because I already have this angle here, this angle, whoops, let me use a different color, this angle, this angle, this angle, this angle. What I'm going to look for is my last angle E, which I was never given. And so with that, I'm going to do, let's see, 540 degrees, take away what I know. I know 90, I know 90, I know 88. You know what? Let me do this. Let me add them all together. I was given 90 degrees. I was given 90 degrees. I was given 88 degrees. And I was given 132 degrees. In total, we have 88 and 132. I just want to double check my math. 132 plus 88. 132 and 88 is 220. And then plus 90 and 90. So we get a total of 400 degrees. So we have a total of 400 degrees for the amount used. But there are 540 degrees in the entire thing. So 540, take away 400, and I get 140 degrees. So angle E, the measure of angle E, equals 540 degrees. No, I'm sorry, 140. All right, so what does that mean? That means that angle A and angle R match up, they're both 90. Angle P and angle T match up, they're both 90. Angle C matches up with W, which would be 132 degrees. Then measure of angle D down here is 88 degrees because it matches up with angle S. And then angle B is our last one, which we just found. So measure of angle B equals 140 degrees. Okay? So with all of this, we found the measure of angle B. I didn't really answer the question until right now, but I'm going to say the measure of angle B is equal to 140 degrees. All the work I did for this, I think the next question is going to ask me some of it. So, oh no, that was it. I really didn't have to do all this other work, but I really now have the rest. So you know what? Why don't I just write it out? Because I already did all that work. Let's get some credit for this. So the measure of angle E, so the measure of angle E is 140 degrees. The measure of angle D is 88 degrees. And then the measure of angle W is 132 degrees. You know why it's good to do this? Because I know we didn't answer the question. The question was asking about angle D. However, B, sorry. But we were able to do all of this work, and what it really does is it gives us the ability of solving all of my pentagon, which a question could ask me one day. All right, next one. It is given that the triangle WYS is congruent to triangle MKV. So it wants us to find the angle K. So check this out. They give me Y. They give me Y. They said measure of angle Y equals 35 degrees. So guess what? The measure of angle K So guess what? The measure of angle K is also 35 degrees. So that one was a little bit easier. It's using my corresponding parts of congruence. Okay, I don't need to know anything else about that triangle. So here is another theorem. If two angles of one triangle are congruent to the two angles of another triangle, then the third angles are congruent. Well, that makes sense because if A is congruent to D and B is congruent to E, then it leaves me no other option but to say, you know what, C, I just undid something. I didn't mean to undo that many. Want to redo that and redo that. Okay. Well, what that means is that angle C and angle F are also congruent. We're not saying the sides are, we're just saying the angles are. Okay, because you can tell visually that these triangles are not the same size. They are the same shape, though. They both have the same angle measures. So if this, then those angles are congruent. It has to be, right? Just based on the degree measure. So this question is asking, determine whether or decide whether the triangles are congruent, justify your answer. So let's take a look. Well, I have angle B and angle D are congruent. I have angle A and angle E are congruent. I have side AB is congruent to side ED. I have side BC is congruent to side CD. And I have side AC is congruent to CE. I have 5 out of, think about this. There are three angles in each triangle. There are 3 sides in each triangle. I have 5 for 5. What I'm missing is one more angle. And I'm not sure if you can see which one it is, but it's angle C. But we can't just call it C. We have to call it BCA. So BCA and DCE. Well, wait a minute. Vertical angles. What do we know about vertical angles? We know that they are congruent. So this was my last piece of information. Nope, hold on. Let's try that again. These angles are now congruent. Therefore, we have 6 pieces of information. So we are going to say, yes, these triangles have that problem happening again. Give me 1 second. Yes, these triangles are congruent. They have 3 pairs of congruent sides and three pairs of congruent angles. And you know what? I really should have said corresponding. They have 3 pairs of corresponding congruent sides, or how about congruent corresponding sides, and 3 pairs of congruent corresponding angles. Okay, that's good. All right, let's take a look at this one. JKL and MKL. So here we are. Let's take a look. What do we think? Do we think congruent or not? So let's see. We have this, we have this, we have this, and we have this, and we have, wait, hold on. What did I just do? Ooh, no, 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 no. This is bad. Because from triangle to triangle, these are the congruent parts. There's this angle and this angle, and this angle and this angle. But notice these sides are not they're not going from this triangle to this triangle. So within this triangle, we have congruent sides, and within this triangle, we have congruent sides. But that does not mean that from triangle to triangle, we have those congruent corresponding parts. Because, you know what this could be? This could be this long. We could have the same angles. We could have the same angles given this setup instead, right? Because if these sides are congruent, that doesn't necessarily mean that they're congruent to these sides. So we have to be very careful. We're going to say no. We're going to say no. We do not have 3 pairs of corresponding congruent sides and angles. And that's it. Okay? That's it for that one. That one's a little tricky because notice in the top one I went from triangle to triangle, triangle to triangle, triangle to triangle. This one, you're stuck within your triangle trying to figure out this part. And that's not true because it would have to be JL and either LN or LM that's congruent to JL, and that's not true. So I actually drew in what we would call a counterexample. Okay? Use the diagrams, and I think this is the last assignment before we depart for this one. Use the diagram at the right for exercises 49 to 51. A, B, C, D, E is congruent to P, F, K, Y, M. So here's what we do know. We know that ky right here is congruent to what? Well, ky is congruent to CD. So what I can do to solve for that variable is say that ky and CD are equal. Okay, they're flipped around here. So it says, what is the value of A? I'm going to say CD equals ky. So CD is 6 and ky is 4A. So I'm going to divide both sides by 4. And so A is equivalent to 1.5 because 6 divided by 4 is 1.5, or 3 over 2. So that's the value of A. And now what I'm going to do, and I'm going to change this to purple, sorry, because I'm just trying to alternate colors. Now in orange, I'm looking to solve X. So X right here, FP is congruent to AB, so I'm gonna, or PF is congruent to AB. So AB equals PF. Oops. No line segment if we're talking equality. So AB is 10, and PF is 4x minus 7. So I'm going to add 7 to both sides. So I get 17 equals 4x. I'm just making sure I'm doing everything right. Yep. Okay, divided by 4. 4 goes into 16 4 times, so we actually get 4 and a quarter. So x is 4 and a quarter. Okay. What is a perimeter? Well, of this one. Well, the perimeters will be the same, so let's look for the pieces. So this has to be 10 because it has to be equal to this, right? Whoa. So FP is 10 because AB is 10. Yeah, could I have evaluated X in there? Yeah, 4 and a quarter. So 4 and a quarter times 4 is 17. 17 minus 7 is 10. So I got that piece. And then I get 4A is 6. So I'm going to get that this is 6 because 1.5 times 4 is 6. And then I'm also going to get, let's see, we have 11. 11 is going to be here. And then 5, so 11 and 11. Then I'm going to get 5 and 5 here. And then 8, I'm going to get 8 and 8 right here. So really, I could have just found the perimeter of this one. I could have found the perimeter of this one, and it's the same perimeter as that one. Whoa. Okay, so the perimeter is going to be 8 plus 6 plus 5 plus 11 plus 10. And so let's see, I got 10, 20, 10, 20, 21, 26, 27, 28, 29, 30, 31, 32, 40. So I'm getting 40. Let me just double check my work. 8 plus 6 plus 5 plus 11 plus 10 is 40. So perimeter equals 40 units. Okay. And that's it for that one. I mean, we have one more question here. So if H is 66. This is a different problem, okay? So we're done with this pentagon one. Okay. This one, triangle HLN is congruent to GST. So H is 66, so I'm going to put 66 here. So if H is 66, we know that G is 66 because of the first ones and they're congruent. So S is 42. So S is 42. So L is 42. Notice they gave me a measure in each one. They want me to crisscross these. They gave me S and they gave me H, and they want me to use the information that H and G are the same and L and S are the same. So you need to interact with both of them. And so what is the measure of angle T? Well, what I'm going to do is I'm going to do 180, take away 66, take away 42. That looks like, let's see, 60 and 40 is 100, so that's 80. 80 minus 8 is 72 degrees. So this last one is 72 degrees, and this last one here is also 72 degrees. So the measure of angle T is 72 degrees. And there we go. That's it. Okay. That is it for our first lesson. We will do all of the rest of this stuff in class for the bookwork, for our practice bookwork. Okay, both of these, which seems like a lot, so we will get through as much as we can in class. And it looks like, yep, it looks like also you'll have some IXLs for homework. Okay, and that's full one. Good luck.